So again, welcome to the Unreal Learning Nugget, or the ultimate Unreal Learning Nugget, about procedural content generation, or the cool new feature called PCG. So in this, I think it will be probably 19 hours. I will try my best to give you a quick introduction to this topic. It's a big one. It's like doing an intro to blueprints or control rig in 60 minutes and expect everybody understands it, with a tiny difference that whatever I'm saying, it's not documented and there's not much information going on in PCG. So I will try my best to find the right pace so everybody can follow along and make it as easy as understandable as possible without trying to go into detail. So if there's something, if I'm too fast, if it's hard to read, or if I have to repeat something, please just let me know. I have Discord here on the second screen running, so I will try to catch as much as possible. Before we start, a few things about me. I'm Daniel Rath, as I said, and probably most of you know me from the Sum of Unreal or just the Discord, or this guy on Discord that is always telling you when you post in the wrong channel. Most of the time it's me, so yay, making friends. I started with 3D when I was 14, so I think it was Counter-Strike, and actually it was the cool spray logos that everybody had. So I learned Photoshop, and then I learned to write in my cool nicknames that you have with 14 in a 3D typography in Cinema 4D, and then spray it everywhere on D-Dust and
what was your
losing
nickname?
all the time.
Tell us your nickname.
I think the most used one was Super Grobi from the Sesame Street, or Grover. Mm-hmm. So nice. Yeah, it's really tough, isn't it? I mean, it's a blue puppet. But yeah, that was my start with 3D. Then I studied 3D and animation and visual effects and started to work in the industry in 2010. So I have a few years now behind me of doing this professionally. I'm more like, since then I'm actually working as a 3D generalist with a focus on modeling, texturing, lighting, and problem solving. But since just being an artist is a bit too boring, I switched over to supervisor roles, so lighting, CG, and VFX soups on different projects, from VFX movies to animation movies to commercials to previs to whatever. Everything that has 3D involved is kind of my cup. And I am an Unreal authorized instructor since 2022. I think the Summer of Unreal was actually my first big thing where I was officially authorized, thanks to Stefan Otten, where I had the pleasure to meet quite a few people here on the Discord server in general. Regarding tools, besides Unreal, of course, I'm mostly using Houdini, Maya, Nuke, Substance Mari. So if there are some transfer questions, or it's like, because this whole PCG topic is really Houdini-like, if you have questions like this, please feel free to ask. If it's a Blender topic, I'm sorry, I'm out. I know with geometry nodes, there's quite a few things happening that are similar, but I have no clue about Blender. So what are we going to learn today? The first one, actually, there needs to be a check mark, because you will learn what PCG stands for, and it's procedural content generation. You will discover the idea behind procedural world building, because I think we will use this P in the word all the time, but what is procedural world building and why should we even care about it? We will create a first PCG setup and have different actors interact with each other to see the full potential, and we will control density, scale, position based on static mesh actors in our scene. So here's the outline of the presentation. It's almost done. So first, procedural world building, as I said, I will show you a bit of PCG and a few examples, the editor, and then it will be the hands-on part. So that's probably the one most people here are looking for. So I think I already saw this GIF. It's probably in the Discord chat. I think Samuli posted it. It's probably my favorite GIF in the world. If somebody asks me how it is like to be a 3D artist, it's this one. And why do I have it here? It's like, let's imagine you have this guy behind you. It's the art director. It is your supervisor. It could be your brother, son, girlfriend, or yourself. But you're always trying, you're always moving, adjusting, and you're never really sure what's the best thing is. And that's the big reason why we want to have procedural worlds. But imagine, or just imagine, it's not just the toilet. And in most cases, the scene is not only a toilet. There are a few other things that needs to interact with the position of one asset. So this guy is lucky, it's one asset, but as soon as it's a forest, it will be a pain, the updates will not be fast, and just from my experiences, at some point, you just stop to play around, improve your scene, because moving one asset will create heaps of other works, and you just agree that's 80%, we're fine, we will just stop here, and we will never reach the 100% because it's too much work. And that's why we have procedural world building. Procedural world building is here to save it, to make life easier. And the first thing that I mentioned is the big flexibility that we gain by using procedural world building, because all the changes we are going to make, they're easier. They're non-destructive and we're not messing with our scene. So if I have a proper setup, I can, let's stick to this old example, I can move the toilet and the toilet will, or the position of the sink will interact and it will not intersect. The other part is, and that's always something for bigger projects, is the consistency. So let's imagine you define a forest. The forest needs to follow a logic. So you're always like, I have on this position, I have trees. Beneath the trees, I have certain type of bushes, but the terrain underneath can't be steep, otherwise I will have rocks and so on. There are always certain rules in nature. You will have the same logic and you can move it to different maps. So just imagine you create your favorite, or create a wonderful forest scene, and then you hand it over to another artist and tell him, hey, can you do the same one? And he will do it different, or she will do it differently. So with handing over a PCG system or any form of procedural world building, they can just adapt, apply it to different worlds. You also have more possibilities, because normally you have something that we call a random seed. And just by changing the random seed or just one input parameter, you will see different results. So just changing one number will give you different results. In Houdini, you would create something that we call a wedge. You would render 100 versions, and then it's like, I like number 5 and number 6. Let's stick to them and keep them and work with them. So more options with less work. And it saves a lot of time. Maybe not at the beginning, because kit bashing a scene is way, way faster than thinking about rules. With rules, we have to find a system, a logic behind, but once it's set up, it's faster to iterate, to change, and to adapt in general. And it's simple things going from changing one tree, going from a pine to a palm tree, easy. Or just changing the terrain, also easy. You don't have to do it once it's set up. So procedural world building should be the way to go for any kind of bigger projects where you still need flexibility and have enough time to prepare everything. The last one that is not here, but that's really important for me, it's a procedural world is most of the time believable or more believable because it's following rules. Even if the rules are completely bonkers, it makes kind of sense because they have rules and it's easier to explain. So I think everybody here is looking for something that is believable and people like, so I think also a good point. Let's have a quick look on PCG in general. So as I said, procedural content generation framework, but we will just stick to PCG. And in my notes, I always had like ultimate learn nuggets, so ULN PCG, kind of confusing name, but it's short, it's 6 words, 6 letters, we go for it. The interesting part of PCG is it's new. There was a version at 5.1. There's now one in 5.2. It's still in a really early beta experimental stage. That's what I said, like there's no documentation at the moment. And it's not really stable. And there are big changes, even going from the 5.2 beta or the early access to the 5.2 stable release. They changed nodes. So whatever you learn today and you read about PCG, take it with a grain of salt. Even tutorials from 2 months ago might be outdated, or even from last week. It's tricky, but it's fun, and it's a plugin and it works natively in Unreal. Big plus points. The interesting part about PCG is it all works with points. So you don't think about the actors. The position where you think about the actors is when you replace a point with an actor. But most of the time you have like gray cubes flying around all the time and thinking like, oh yeah, I like this scale. Let's see what it looks like if I replace it with a bucket or a tree or whatever. So it's point-based, something that is quite familiar, I think, for everybody here that has a bit of Houdini knowledge. The most interesting part, or the biggest task at the moment, is for instancing and transforming. So you can't manipulate geometry, you can just place and move geometry. But it has the advantage, then you will see the updates live. You can even animate them and add them to sequencer. So when an object moves from left to right, it will automatically update your PCG network. It takes a bit of resources at the moment, and it's a bit hacky, but it's working. And I said it the last time as well, probably something for everybody that is into blueprints like Robin, or everybody that's been to a blueprint class. Nodes are like blueprints here. So you can create custom functions, and I will show you one at the end of the course. We will not create one. This is probably something for PCG too. But you can just create your own setups. If you don't have a node, if you don't have a function, just build blueprints and add them to your PCG network. So everything feels like Unreal, not like a third-party application that is embedded here. So just to make it more clear, I think everybody has seen this demo from the GDC, but this was the presentation of PCG. So here you see a small environment setup, and they place a PCG setup, and suddenly everything is aligning. They're adding trees, they're adding all the objects, they're adding overhangs just by adding one object. So it's not just like one big asset, it's interacting with the environment. Something that is otherwise really, really painful. And as you can see in a few seconds, they will change it a tiny bit, and you can see after a bit of thinking, it will update everything. So now we have more space for the riverbed. The distance from left to right side is too wide, so the log will be removed, and so on. It will all happen automatically. And of course, you can still add assets on top. So if you like your PCG position and you want to have a hero rock somewhere, still fine to add it. But yeah, in general, it's pretty impressive what Epic built here. And the next one, this is more one, I think I posted them in the Discord, but I just wanted to show you the difference between the network and the video. And the overlap is wrong here in my presentation. But I just made this small setup where I just moved the monolith, and everything in this scene is based on the position of the monolith. So when you move it, the apes are in different position, the rocks are in different position, there's no intersection, there are small bones and skulls near the monolith. So for everybody that knows Space Odyssey, it probably makes sense what I'm saying with apes and skulls and all the things. And here you can see a part of the PCG network that I built to create this one here. So it's not too complex, it's messy. I could have cleaned it up, but honestly, this was my first project, so I was just happy to get a result. Second one, same idea, same in another network, but here in this one, I'm not driving it with a static mesh actor, but instead with a spline. So there are two spline curves, and the spline curves are creating the yellow brick road, so that I always have a Dorothy and a scarecrow standing in the scene, a fence around the path, and sunflowers everywhere. So everything 100% fully procedural. There's no asset placed by hand except the splines. And that's with examples. No. This one here is important. I will probably enable key logging on my screen, so you will see what I mean. But these three shortcuts here are the most important ones. It's D for debugging. Debugging means you will see the output of the node. You will force it to show it. A is for inspect. And in an old version, it was I. So, but for me, it was always A. It's kind of confusing, but maybe check it in your scene. A will, with inspect, you will see all the information of all the points on the bottom part here and the analytic parts. And E is for enabling or disabling, just a toggle. So if you want to check what a node is doing, most of the time I just recommend hit E, disable it, enable it, and you will see the result and the output there quite fast. As a small tips, At the moment, it's not really stable on nanite geometry. You can use nanite to instance, but if you want to place it on a nanite surface, it's not really recommended. I'm not really sure if that's because it's like tessellating differently per frame, but for me, it crashed quite often and it was not really pleasing. If you create a static mesh actor, it will have collision enabled. This will take quite a long time to calculate the PCG network. So if you don't need collision, disable it. We don't need to have collision on every grass, on every flower. That's completely fine here as well. The last two ones is more, you will see it, the boundaries of the point is the most important part, because this will define how big your object will be and if they collide with other objects. And there's also the density. The density drives the amount of points that are visible. So object with a density of 1 will always be visible, for example. And I think that's enough theory as the last one. I just have a few resources here. I will post them in the channel as well at some point. But it's like I said, it's not really documented at the moment. That's why I would always recommend the channel from Adrian. He is a developer from Epic. He is super, super active on the Unreal Slackers Discord. Sorry for making advertisement for another Discord server, but he's doing a fantastic job of helping people. There's also an unofficially FAQ server that was started by him on the Unreal Slackers, and there will elements that will be added all the time. I like the Free Time Coder YouTube playlist, also a lot of good information, tutorials, step-by-step information. Again, I think it's like 2 months ago, so it might be outdated to a certain degree, but it's good and it's really, really well explained. And as the last one, there's the GDC video from Epic. And with that said, I think we're done with theory and let's go to Unreal. So we will...
Helene, wir müssen kommen, essen.
The food is ready. Let me just mute people. Okay, so what are we going to create? We will create a landscape with the fox statue in the center. So this is coming from Quixel Megascans. As the first tool, so we will build layers on top of each other. As the first layer, we will cover the whole landscape with some kind of grass. Really easy, but it's the perfect example. Then we will add random rocks and making sure they're not intersecting with the base of the fox. Then we will add a path and remove all the rocks that are intersecting with the path and also the grass, of course, as well. We will add lanterns near the fox, not everywhere, not like the rocks. They will be just close by to the fox. And around the lanterns, we're going to add flowers. And as the last one, we will just add one gate that is procedurally sitting on the path. So these are the steps that we try to tackle in the next, let's say, 60 minutes. Or maybe 50 if we are fast. Okay, so let's open up Unreal Important 5.2. I hope everybody got my message and everybody installed the right version and downloaded the file. If it's too fast or if you can't follow along, of course, it's recorded. So it's completely fine to just sit back and listen. And when you open the file, you will see a scene like this. This is just the default map. And I'll wait before we go into details. I will just make my interface a tiny bit bigger because I have the feeling with a 4K screen, oh, that's huge. And I will enable a key logging on the bottom screen. So I hope everything is good readable and everybody can see it and it's easy to follow. So what we do is we will go to content and there is a map called UNL main. So please open up this one here. And we will just have a quick look. Then I will show you a part first and then we will do it together, all together in a follow along part. So in this scene, it already has a landscape object. Yes, it is a bit boring, it's flat, we can change it, but it's a landscape. And we have this Fox setting here on the statue in the middle of it. It's just a Quixel asset. It's a regular static mesh actor. And that's all that we have in our scene. So remember, first one, cover everything with green grass. To do this, or let's start with the most important part, and I get a bit of flashback from my character rig classes. First one is always making sure that the procedural content generation framework is turned on. It is turned on in this scene, so I'm 100% sure about that. But for the future projects, whenever you want to get something with PCG and you can't find the nodes we're talking about in a few minutes, make sure that the plugin is enabled and PCG is running. So PCG is turned on. There is already a folder called PCG in your scene. So let's go to this one, do a right click, and then we will go to PCG and we will create a new PCG graph. So please, everybody, do this now and then put your mouse away for a few minutes and I will show you the first things. So that's a lot of shift clicks. So I will just call it PCG Fox and I will call it demo because I already have a PCG Fox in your scene. Let's fix the typo. Okay. So now I have my PCG actor. And yes, it's the only PCG that we plugin that we need to enable. Okay. So I have the PCG Fox demo and I will just drag it into my scene. You will see it, it's just like any other volume in your scene. I will move it to the origin and I have it here. It's quite big. It's not really a problem because we are sampling the scene, but of course it's recommended to just make it smaller. So to make this one here smaller, we just select this PCG Fox and go to brush. I think it was called brush size. No, it's not. It's on the bottom. I'm always missing this one. Oh, it's brush settings, I'm sorry. And change the values to 100, 100, 100. And you will see that the bounding box is getting closer to our scene, means it is just tighter and less calculation from the outside. Like I said, not really necessary, just make sure that your landscape is inside of your PCG network because there are options to say only create objects that are inside of my box and from time to time you want to make them bigger. Okay. So the important parts, we will just have a look here. It's not really, there's a PCG menu. You can leave everything by default. We have an input type. You can just select actor, landscape or other. In my cases, I'm always left it to default and I was doing everything inside of the PCG network. And we can keep it, but the only thing is when you go to the collision tab and you have the collision preset, just set it to no collision to make sure. So it's inside of here, it's no collision. Okay. So this is just a bit of prep. It's not really important, but it's a bit of best practice that I like to do before I start with my scenes. So let's just open up the PCG network, PCG graph, something that you can do, that's fine. And it's probably easier if you can visualize it on your screen as well. I have my network here, and there might be options where you still have your, where is it? Where you have this menu here on the left-hand side. I disabled it to give you a bit more screen space because PCG is more fun on 2 monitors. It's a bit tricky with the single one because of course I can't see now my update in the viewport, so we always have to work in Windows. So if you have 2 screens, put PCG on a second one and it's way, way easier and way more comfortable to work. So what do we have here? We have an input node and we have an output node. The input node, when we click on this small arrow, we will get all the information. So we have an in. The in is defined, what I said earlier on the node. So when we change, I will just open up again. If we go up and go to the settings and I change the input type from actor to landscape, this inn will become a landscape. But as you can see it here, they are already here. So we don't have to switch them. We can just grab a landscape from here. We can just grab inputs and everything from there. That's way more comfortable and easier to read and later on to debug. Because of course, make sure whatever you do needs to be readable for somebody else. So as the first part, what I said, we want to cover the whole landscape, really important word here, and want to cover it with grass. So that means we grab our landscape, and I will make it now a bit smaller. And please, for this one, wait, we will just repeat it afterwards together, because I think it's really, really important to understand this one. So we just grab the output from the landscape and create a surface sampler. And now nothing changed, of course. When you select the surface sampler and you hit D for debug, you will see that I now have all my points here. I have a quite big amount of gray cubes selected and ready. These are the points that are created and set into my scene. So whatever I'm doing, that's what I meant, like everything will be based on these points. They're a bit big at the moment, and but that's fine. We will just keep them like this. As the next one, and really this is just the simplest way, is I will create a static mesh spawner, and I will go in and select the type of mesh that I want to change and or want to spawn at this position. So I have my static mesh spawner. I will go to mesh entry, open up this one here, and I will select the yellow archangel. That's a plant, and I don't see anything, because as you can see it here, I have still the blue or the dot here. That means I'm still debugging, and the boxes are bigger than my meshes. So if I disable it, you will see instead of the box, I now have tiny little plants here. The reason is that the size is so different is because the bounding box is different, or the size of the boxes that are representing in my debug dialog are just bigger than my plants here. So what we can do now instead, we just have to find right values for this one, because I have the feeling I said we want to cover it, so we need more. And to get more, we can just go into the surface sampler and change the points per square meter and change it to 10. And I will enable debug, nothing changed, because the point extents are still too big. So I'm making the points now smaller and smaller, and you can see I now have a lot of different small points, and we will change the looseness to 0.1 to get a bit more of a random feeling. So now we have a lot of points, and if I disable it, I have a lot of my small archangel plants. It's working, it's not pretty, but this is the easiest or the most basic way of creating points with PCG in your scene. To make it more interesting, we will just add a transform points in between, and I will disconnect the node with Alt and left click. So like with blueprints, we can connect them, and now I have the option here to do overrides. And what I want to do is I want to make the plants bigger, so we can just change it to 2 and the scale maximum to 4. So all the plants here, it looks a bit more like salad at the moment. All the plants here are between a scale of 2 and 4. It's just random values and it's a uniform scale. And to make them less uniform, we can go in and change the rotation. So I want to have a rotation between 0 and 360 degrees in Z. So we can just change it to 360. And now it's already looking better, but the distribution is still quite simple. So we can also add offset values. So I can move everything to -10 and 10. So we now get a bit of jitter in our scene. And now I have a simple PCG setup with all my plants in my scene. As the last big thing, I can add more meshes. So they will be distributed in random manner. At the moment, I have one mesh entry. I will just make this one, close this one, and I will add 2 more. You will see they will disappear because now I'm distributing meshes, but there are no meshes. So we just replace it with another archangel. Let's take 12 and let's take another one. Which one is pretty? I can't remember. Let's take number 3. And now you can see it. We have smaller ones, we have bigger ones, and everything is working. Maybe we could need more. So we can change the points per square meter to 15, and everything is getting closer and closer together, and we have more space, or we covered more space with smaller plants. So this is our basic setup. I hope that was kind of clear, because now we will just repeat the steps together with the values, maybe a bit faster, but with less explanation, because I can't do it much faster. But for now, please, if you didn't do it already, follow me in Unreal, and we will do the steps again from the left to right. So first surface sampler, then transform points, and then the static mesh spawner. So we take the landscape, create the surface sample or sampler, and we will make sure that we have the points per square meter. I had 15, change the point extends to 10 by 10 to 10 to 0.10. We can check it with the D button, and now I have a lot of different points here in my scene. That's good, that's exactly what we want. From here, we will just grab the output and we will add a transform points to get a bit of random variation into this one. And we will change the minimum scale to 2 and the maximum scale to 4. We can also disable this debug and debug this one. An important thing is you can have debug on multiple objects. That might be confusing. There's a shortcut or a right-click menu where you just say disable debug on all nodes or disable debug only on selected. So make sure that you most of the time just have this one dot. And as the last step, we will create the static mesh spawner in the scene, and we will add 3 mesh entities or entries, and we will add archangel flowers to this one. Just pick 3 random ones, doesn't really matter. They're all pretty. Okay, and the last one. And now if I disable my debug, you will see that I have all the different points. We forgot to set the random rotation, so let's change rotation max to 360. And then we will lose this pattern that was visible at this position. Is that so far clear? I'm trying to have a look on the chat. I hope so. I hope everybody was able to follow along, because this is really the basic. And now everything we are doing is we take the setup and just adding something on top, making it more complex, adding more elements and adding more intersections or interactions. So let's select all the nodes and hit.
Maybe we just can ask these over Zoom by raising the thumb.
Sure.
So all the people who can follow, please raise your digital thumb here in Zoom.
Yes, Robin made it.
Robin! Whoa! Okay, most people are sleeping.
Yeah, I think, but I have Robin. I still have Robin, so I'm fine. I'm good to go.
Okay, so I see Volker.
I lost Stefan Otten. I think he was a good benchmark.
So there are a few. Okay. So
okay.
Most people probably wait for the recording.
Yeah. Random rotation is set to 360, but it's completely up to you. You can also change X, Y, Z to just get values. It's more, if your result is not 100% the same, I think it's completely fine. It's more like understanding this whole workflow, and we will do it more often. And in the end, I would suggest take the scene and just play around and see what each value is changing for you and the visual impact. So let's just say we're done with the grass. So what you can do is select all the nodes, hit C, we will get a comment box, and we will just call it grass. Otherwise, you will end up with one of those messy networks that I showed you that I did the last time. And of course, it would be better to have a nice, neat one for the first one that you did. As the next layer, if you remembered from my wonderful slides or the wonderful graphics, is adding rocks in between. And the rocks are actually the same setup, but we want to make sure that they're not intersecting with themselves. For the grass or for the flowers, it's fine, but for the rocks, it's important. And that they're not intersecting with the fox. So what we can do, because we can just take this setup here, the whole one, copy and paste. We will just call it rocks, and we will connect it. And now we have this same setup output here twice. That's fine, but we will replace the static mesh spawner. To see it better, select the static mesh spawner of the grass and hit E to disable this one. So now this one here is not creating any meshes, and we can for now focus on the output of our rocks. So we have 3 mesh entities here, and we can just, instead of the rocks, we will just add stones to it. But I think I only have 1 boulder in my scene. So let's delete all of them and add 1 back in, and we will go to the descriptor and we will look for the mossy boulder. And as you can see now, that's weird. It's maybe interesting, but not what we're aiming for because it's just too big. So what we do is we take the transform points, and instead of setting it to 2 and 4, we can just make it smaller here. So let's start with something like 0.2 and maybe 1. So I would say the values here are looking better. They're still big. That's fine. But we just have too many. And to change this, we can just go back to our surface sampler and work on the points per square meter, and maybe just change it to something like 1, or if you want to have less rocks, if you're not a big rock fan, you can just change it to 0.5 or 0.3. Find a value that you like. Okay. And now when we look at it, it's fine. We can enable the grass, and it's actually not looking too bad. The intersection between the grass and the rock is fine. So we just have to make sure that the rocks are not intersecting with themselves, that we get a random rotation because at the moment they're boring, and that they're not intersecting with our fox here. It's pretty close. It's fine. It's still working. So as the first one, let's try to make sure that we don't have any self-intersecting rocks. So let's extend this node. So when we debug the transform points and enable or disabling the static mesh spawner, you will see that the points there are tiny. They are not as big as the rock. The problem here is that the bounds of the points are bigger, or are too small. And what I said is like, you need to make sure, or everything is happening on the points. So we have to make sure that the points have the same bounds as our final rocks later on. For this, there's a node called bounds modifier. So instead of going from the transform points, or we will disconnect it to the static from the static mesh, and we will create a bounds modifier. And if we enable it, we get the same result. You can see it here. It has scale values, so I can change them and make the rocks bigger. And by changing them into 5 in all directions, I'm getting something that is closer to my rocks. So if we connect them back on, you will not see any difference, but you will see that the rocks, or that our bounding boxes, are actually bigger than the rocks themselves, which is good because we want to make sure it's always better to have a bit more space between the rocks than having intersections. So now I have all the information that I need. I have the size of a rock saved in my bounding box. And now, fortunately, there's one node that we need to add to make sure that we are not intersecting, and it's called self-pruning. The self-pruning is checking the points and is looking for intersections. So if I add the self-pruning in between this one here, you will see that we don't have any intersections anymore. Of course, we have less rocks, but we don't have intersections. And by disabling it and enabling it, you will see that it's actually the radius, it's maybe a bit too big and it's a bit too intense, but maybe it's better be safe than sorry. It's fine. You can go back and change these values to maybe 4.5, 4.5 in all the directions. If you want to have a bit of tighter results, or you can go into the self-pruning node and play with the values here. But this one here, if I disable the bounce modifier, you will see the pruning is not doing anything. So self-pruning is to check if something is intersecting with themselves. And as the last step, because we want to make sure nothing is intersecting with our fox, we need to convert our fox into a static mesh. Let's look for the fox, and then, of course, I just realized that the rocks are looking pretty stupid because they're all rotated in the same way. So maybe before we do the fox, let's go to the transform points and add 360 in all directions to make it less like a rock garden. So I just added 360 to all the rotation maximums in the transform points. So now it's random and it's a bit more natural. Okay. Maybe to check it, I will just move the fox. You don't have to. It's more for us to see it more clear. You can see it now. The rock and the fox is intersecting. Something that would never happen in the real world. So we have to remove the points. To do this, we have to get the information of the fox. And for this, there is a node called getActorData. GetActorData is able to read different types of meshes or static mesh actors or from your scene and feeding them into the PCG network. In our case, I prepared the fox and I added a tag called fox to it. So when you select the static mesh actor, add a tag, I called it fox, and now we're going to read this value and we will create points for all the objects that are called fox. So I will go to getActorData, actor filter. I will set it to all world actors, and we will select actor selection by tag, and I will write in fox. And if everything is correct, you won't get a warning, and you get all the information that we need. I can debug it. Should be able to debug it. Let's have a look. Select multiple is turned on, and get a single point per actor is important. Because then if I debug it, I'm getting like the bounding box of my static mesh actor. And now what I have to do is I have two different point clouds. I have this one here for the rocks, and I have this one here for my fox. And what I have to do is I have to subtract or remove it or create the difference between all of them. And for this, we will just go after the self-pruning, get a node called difference. The source is our main point cloud, and the difference is our getActorData from the fox. So if I disable it, enable the difference, you won't see a difference because you have to set the density function to binary, and mode to interfered is correct because everything is either intersecting or not intersecting. And now you can see it. This one rock here at the bottom is gone, and I can connect everything back to my static mesh actor. And now I don't have a rock intersecting with my fox. And if I move the fox in my scene, you will get real-time updates on mouse up, and everything that is nearby will disappear. And now we have our first real reason, or first rule that is controlling our environment. And if we enable the static mesh spawner again, you will see now we have some rocks inside of our grass and the fox. So it's like the biggest part is done and we are able to proceed. Questions about both setups here?
There are some in the Discord, if you may look over there. So for example, Charles was having one just a minute ago.
If we want to this one, yes, it's complicated because then you will first, we are not going to do this because it's maybe a bit too advanced, but you would get the position from the actor that we have. And then there is a node called, is it the mesh sampler, where you can select a static mesh and it will distribute points on the static mesh. And then you copy these points to the position of the statue. So this will create like a lot of points, and it's of course way more cleaner. In our case, it's fine because we have a square bottom, but we can do this with different setups. Maybe if we have time, we can have a look, or I can show it in another example or in PCG part 2.
All right, there's one more question.
Mm-hmm.
The difference if it can be bigger. Sure, what he means by that.
So does it mean to have a bit more space around the rocks, maybe, or around the fox? Because if that's the case, then yes, the easiest way is to just scale this one. As you had with the bounce modifier, I can create a bounce modifier after the fox and add it for the difference. And now if we plug this one in, and I will just add my debug here, I can just make it to like 5. And let's do 5, 5 to make it more clearer, 5, 5, 5. And now I have around my fox a big box, and there are no rocks in them. So you can offset them and you can force it. And that's the same one that we will use later on to place the lanterns around the fox, but inverted. Let's remove this one for now, so we're all on the same page here. Okay, because then I would love to switch. Would love to switch to the path. So to get the net to answer Charles' question is the mesh sampler. For the mesh sampler, you're able to put in any mesh. So I could add the fox, what's called statue. And if I debug, you will see that I got now a lot of points on the surface on my fox, and now I just have to copy it to the right position with the copy node. You will know what I mean with the copy node in probably 10 minutes. Okay, so let's go to the path. Or let me check if I missed something. No, path. Path is all based on a spline. So far we just worked with the static mesh actor, and we worked with the landscape object. And now we will add a spline. And a spline has different options. You can use a spline as an area, so everything inside of spline will be treated different, everything outside of a spline, or just copy points along a spline. In our case, we just want to copy it along the spline. And to make it easier and more flexible, we will just create a blueprint actor to do this. So when you open up your content browser, let's just go to PCG and create a new blueprint class and set it to actor. And we will call it BP path. So just a regular new blueprint class. I will leave it open, just a regular actor, nothing fancy. And we will open it up. And I hope everybody knows how blueprints are working. Actually, you don't have to in this case, because we will just add a spline. And to do this, I now have my BP path open. On the top, we will look for tag, and I will add a tag here called path. The advantage now is whenever I'm using this blueprint, everything is already predefined and it's working in the way that I need it later on. And when you go to add, we will just look for spline. This will give us a spline. We can remove the default scene root to make it a bit cleaner. And now I have a blueprint with just a single spline in it. And that's all that we need to do. To make it a bit more user-friendly, you can look for the width, not size, the scale visualization width. You will see something like this, because that's something that PCG can take into account. So if we scale it wider, it will be scaling all the points. So enable scale visualization width in your scene. And if I was too fast, in your scene, there is a folder called result with PCG, and there is a BP PCG pass, and you can just drag this one into your scene. It's exactly the same setup. So for now, I will use the one that I just created, and you will see I now have my tiny little pass here. It's probably hard to read on your side, and I will just grab the point, move it to the side, and move it over here. And I will just set the position back to the ground. So now you can see, it's really hard to see. I have my points here, and I have another point over here. Maybe to make it easier, let me just open up my Fox and disable the grass for now, so you can maybe see it better. So I have my points here, and I will just add one in between. Can also be a straight line, can go wherever you want to. It doesn't need to end at the Fox. So it's a super simple spline, just going from one side to another one. And that's all that we have to do, because now I want to take this spline and I want to distribute points along the spline. For this, there's another node. If you remember, we used the get actor data, but now there's a node called get spline data. And the get spline data is actually exactly the same as the get actor data. You just select it and change it to all world actors and actor selection by path, and we will type in path, because that's how I called my blueprint or my spline. No errors, so it was able to manage to find a world actor called path or with the tag. If I debug, you will see that I now have like my big cubes here along my path. I can disable it, right? So you can see them. Now I have points here. It's not a surface, it's a spline. So now we just need the spline sampler. Spline sampler, we will just create it here. And if we debug this one, we have the same, but now we have a bit more options on the spline sampler. And the important part is, as I said, we have we can create points on splines. We can create points horizontally, vertically, or in the volume, or on the interior. So all different ways. In our case, it's not a closed spline, so there might be issues with volume or interior. But we can just set it to on spline because we want to scatter points along the spline. And I always prefer to use distance, because subdivision, when you use subdivision, it is based on the points that you created. When you use distance, it will evenly distribute the points along the spline. So we change it to distance and type in the distance increment 100. The splines, or the points, they have a bit of a weird shape. So let's go in and change it with the bounce modifier to make sure that we have something that looks more like squares. And type in, set it to scale, and let's type in 1 and then 20 on Y, 20 on Z, and 20, 20. So we can now get something that is more looking like a curve or like a path. And now we want to add objects here, or in our case, I want to add decals, because let's say the path is just muddy. So instead of using the static mesh spawner, we can use a spawn actor. A spawn actor can spawn different types of meshes, not just static meshes. Not surprising by the name, but you can spawn blueprints, lights, decals, whatever you want. Of course, it can get heavy. So if you spawn a few hundred lights in the scene, might look cool, might crash your machine. As an actor class, we will just type in decal. So it will create a decal actor. And on the option, instead of collapse, you just select no merging. And now you can see it. I will disable debug. I have a lot of decal actors here in my scene. For the spawn actor, we will just change it. So I have my decal, I have my template actor, I have the decal. We will just open it up and look for the decal. It's called a decal material, and we will look for, I have to look it up, I think. Let me have a look that I'm not spawning something completely wrong, and we're suddenly standing in a path of blood. It's called wet_soil. So if we select it and we will spawn it, you will see that we now have this huge path made out of soil. It's maybe too big, so let's add transform points in between, and we will recap it in a few seconds. And we will add the transform points in between, and I will change the values to, I don't know, maybe something like 0.1, and maybe on the other side to let's do 0.4. And add a bit of random values. Of course, as you can see, the decal is not perfect. The decal is not fading out to the border. That's something that we can change. It's just an example. So if you have a bit of nicer texture or nicer decal, you can create like different patches. You can also create footsteps if you want to. But we can also increase the amount of decals that we have by changing the distance increment. So if we change it to 50, we will get more, and the path is getting a bit more dense. So to recap it, this is kind of, so we created the spline, and I read the information with the get spline data by all world actors. We're looking for a tag called path. Then we are sampling the spline, and we're looking on the distance. We are subdividing it based on the distance and creating 50 steps, or the distance of 50. We changed the modifiers to get something in the width that is more like the path. Transforming the points to get smaller decals, and then we use the spawn actor to just spawn decals on the position of the points. And now if we enable the grass, you will see that our grass is muddy and the grass is still there. So two things that we have to fix. By selecting the static mesh actor, just search for decal, and you will have the checkbox that you know from static meshes with receive decals, and receive decals. Turn it off. And we do the same for the rock. And now we have only the path barely visible under the grass. So what we have to do now is we have to remove the grass and the rocks in the position where the path is. The decals are actually following they are aligned along the spline. So when you sample or put something on the spline and you don't have a random rotation, it's already aligned. The easiest one is to check it, because Charles asked, the easiest is to just, instead of using the spawn actor, and let me show this one. It's actually want to do it later, but maybe it makes more sense now. Let me disable the spawn actor and go to the bounce modifier here. You don't have to follow. This is more an example. In the settings or in the debug settings, you have the option to select a debug object. In the moment, it's a PCG cube, but you can also instead use it was there already. Is it called? You can use the PCG axis tripod. So instead of cubes, we will have the tripod here. And here you can see the alignment of the points. So here you have the rotation of each point. You can use it for different ones, but as you can see, it's perfectly aligned along the spline. You can use the PCG axis tripod also for other things, not just for spline sampler. But if you don't like the cubes, or if the cubes are not helping and you need the rotation, change it to PCG axis tripod and you will have a better way to debug orientations. So let's turn everything, or let's just turn on the grass. Let's ignore the rocks for now. Because now what we do is we take the points, and you remember the difference setup that we already got here, and we will use the same one for the pass. So from transform points, we will pull out a difference node. We will set it in the density function to binary, and we will add it to the static mesh spawner. As you can see, nothing changed because I don't have a difference yet. So all I have to do is I have to make my window a bit bigger for now. What I do is I'm pulling out the out here and plug it into my difference. And now you can see all the points that are of the grass are gone because we removed these points here from those points. And if you want to have a bigger gap, you can just add modify boundaries in between, or bounds modifier. And let's do this now. Add it in between. And now if we modify the bounds to maybe something like 3 by 3 by 3 by 3, you will see that my pass is getting wider. And with this node, I have a nice and easy control to option to control the width of my pass here as well. And if we enable the rocks, let's enable them. Now we have one rock that is intersecting. So we can do the same. We have the Fox information here. From the Fox, we can pull out a merge node, and we can add the rocks as well, the pass as well. So we have now here one node where the pass and the Fox is combined. And if we plug it into our difference, as we did before, and disable it, you will now see that there's no rock on my pass or near the Fox. And the pass is clearly visible. To answer, there was a question regarding bounds and transform points. The transform point is controlling the mesh later on that is instanced. The bounds is modifying the size of the point. So when we look at the bounds here, it's just making the bounds bigger. So it was small points, or maybe it's easier to do it here. It's making the bounds bigger, but it's not changing the size of the decals. With a point modifier transform, you will also change the behavior of the static mesh that you're going to spawn afterwards. I hope that's made it more clear. Let's go through, make sure that nothing is debugged that should not be debugged. But now we have our first setup where we can move the spline and it will automatically change our position. So when we open up our browser and go to the BP blueprint spline, and if I move it, you will see that the path is changing, and the same is happening with the Fox. So that's the same idea as I did with this Wizard of Oz video, where I just created a yellow brick road based on the position of the spline, but I didn't use decals, I just used meshes. Okay. 2 more things to do, and then we are done. So I think we are not too bad with the time. Let me have a quick sip of mate to stay awake. Okay. The next one, lanterns and poppies. So at first, the idea is, of course, this fox, there's a special meaning, and people that placed the fox in the middle of nowhere, they wanted to add lanterns to it to illustrate or to illuminate the environment. We are not doing the whole illumination, we're not adding lights, but I want to, in this case, add lanterns that are near our fox. Not like the rest that is distributed everywhere, but really just in an area, in a random area around the fox. To do this, we will first, that's a bit lazy, I know, but we will just copy the rock setup. Because we also want to just place them everywhere and then remove the unwanted ones. So let's copy our network here, the rock stream. Just select everything, Control C, Control V, and connect it back on to our landscape. And as a best practice, let's disable the static mesh here, the static mesh here, to really just focus on the landscape, on the lanterns here. When you copy the nodes, you lose all these cross connections. So I have to make sure that my merge is still here. So I now have more rocks. But we don't want to have rocks, we want to have lanterns. So as you know, first thing that we're going to do is we go to our static mesh spawner, and instead of the S mossy rock, we will select the Japanese stone lantern. So let me make this window a bit bigger again. And look for the Japanese stone lantern. We will now have really weirdly placed random lanterns. The reason is, of course, it's our transform points, because for the rocks, we wanted to have them rotated in all the different directions. For the lanterns, maybe let's rename it to make it easier. For the lanterns, we don't want to. So we only want to have a rotation offset in the Z-axis. So let's remove it, set it to 0, 0 and to 360. So now I have lanterns and I have them in different sizes. I think something that is also not really realistic. So if you build something like this, you would probably build them all in the same size. So let's remove the random scale here as well. And let's go for something like 0.8 minimum and 0.8 maximum. So all the lanterns are in the same size and are in all evenly distributed, but also randomized. If I enable my rocks, you will realize they are in the same position because, of course, I copied the setup. Two things to just fix this and change it is the random seed. Each spawner or surface sampler has a random seed. The random seed is just a random number that is giving, adding a certain value. The interesting part is by having a random seed, everything is reproducible or deterministic. So every time you open up the scene, it will not change. It will always give you the same result. By changing the value from a 7 to a 6, you will realize that everything is different. So all the points are on a different position. And that's all that we need to do to create our lanterns. So now we have them here and they are in a different position than our rocks. Of course, we can decide if we want to have more or less, but that's up to your creative decision. So you can just change the values if you want to. For now, we will just leave it like this because it's more about the bigger idea. Let's check the bound modifier because we set it up for the rocks. Remember, we just changed the values to 4.5 to make sure that the bounds, because we wanted to use the self-prune, that the bound is matching to our lanterns. In our case, the lanterns are actually way, way smaller than the rocks. So let's change the bound modifier to something smaller, maybe to 3 by 3 and 3. So I think that's better from a base. And in the height, of course, the lanterns are higher. So let's change it to, let's do 15. It's not really important because we're not building something in height, but now we have a setup here that is covering all the different lanterns. There were some rumors that Epic is probably building get bounding box tool here as well. So you don't have to do it by hand. It will just analyze your mesh and it will create a bounding box that is perfectly fitting. Maybe you can already do it with blueprints now, but not with the base tools. The self-pruning, you remember this hopefully, it's doing the same. It's just deleting all the points that are intersecting. and the difference is removing all the points on the pass. So now I have a lot of lanterns. And now we have to make sure that they're just close to the fox. Okay, so to do this, of course, we have to get the position of the fox. But we don't want to have an intersection. We want to get the distance from the point to the fox to make sure that everything is just in a certain radius around the fox. And to do this, and I already used the right name, is after the difference here, we will just create a node called difference. Surprise, surprise, the difference node is the distance. Maybe I need to drink more mate. The distance node is getting the distance between point A and point B, or object A and object B. So if we connect them and we debug, we will get points, nothing changed, because we still have to set the target. And the target is our fox. We have it here. We can just copy this get actor data, put it over and maybe add a comment and call it fox. It's easier to grab later on. And now if I connect them, still nothing. And we just have to make sure that on the get distance node, we have to say set distance. This will set the distance value. That's the one that we always visualize based on the distance to the fox. And our scene is not that big yet, so we can change the maximum distance of our scene to get nicer values to 800. And now you see it already. We have like a gradient fall off going from the center, from black to white to the border. And all we have to do now is we have to filter our density and remove all the points based on their density value. And to do this, we can just go to the distance, grab a density filter, and select it, and connect them here as well. And let's debug the density filter. You now see it. I only have points on the outside, nothing near my fox. And we can just select invert filter, and we only get points near the fox. So if we just, so we'll see it now, and now we can change the lower bounds, and we can see how far away we are allowed to have the lanterns, and we have full control about the distance and the distance fall off. We can also change this value, so we make sure that we create something like a ring. So different options. We're just utilizing the density value, the black and white value, going from 0 to 1, and removing points based on their density value. There's another node that is really helpful to make it a bit more random. That's a density noise. This will create random values. So when we go to the density filter, and we will create the density noise node, and we will debug, you will see that those lanterns now have random values between 0 and 1. And if we use the density filter here, we can go in and toggle them and change all the information. And now we can enable everything and see what we got so far. And then I will tell you one tiny little secret for everybody that is working with my file. And now we have lanterns near the fox, a pass, green grass that is not intersecting with the pass, and random rocks. So there's actually only one left, only 1 point left. That's the poppies. Before I show you the poppies, and I try to not say it from the beginning on, I hope everybody was able to follow. If not, as usual, I have in the result PCG, there's a PCG Fox network. This is my master scene. I already have it here. It's exactly the setup we're going to build. The reason why I kept it a secret is, of course, I know a lot of people are just ignoring everything and logging out, zooming out. It's like, look, I don't have to do it. I can just copy it later on. If I need a PCG setup, I can just steal it, or let's say borrow it from somebody else. And I think here it's really important to understand it. So that's why we tried to focus on this part here up front. But again, there is a result. So if you want to follow along, or if you're watching the recording and you don't have like the master file or way to ask, just go for the result. The last one is the poppies. And the poppies is special. It's already pointing a bit in the direction from the question earlier on about placing points on a certain position. And what we want to do is I want to disable everything except the lanterns. What we want to do is we want to spawn points around our lanterns. And we know that each lantern is already a point. So that means is we have to create something like a point cluster or a group of points or a grid, and have to place it at the same position that the point is here for each lantern. And there is a node called create point grid. So let's create this one here. It's called create point grid. And let's debug it, and you can maybe see it, and I will just scale them bigger to make it more visible by changing the value here to, let's say, 0.2. With create point grids, we will create random, or not random, we will just create a perfect grid that we then can use for different things. At the moment, it's really just simple, and it's just not a volume, it's just flat. We can change it to volume, then we get something like this. But we only need points on the ground, so we don't have to create it as a volume. We just need a flat surface with evenly distributed points on them. The size is a bit too big. If we would do this, I think the whole landscape would be covered in flowers. So let's change the grid extents to something like 100 by 100. And now we only have 4 points. So we have to make the cell size smaller to create smaller points. And I think that's a bit too small. That's a lot of points. Let's maybe make the cell size a bit. Let's keep it like 50 for now. We will make them bigger because we need more flowers. That's not enough. Point scale is disabled. Point scale is only enabled in this preview if you change the scale method to absolute. Relative will always show the value as it is, and relative or absolute is giving you an override. Otherwise, this point scale is disabled. Okay, so what I want to do now is I want to take those points and I want to copy them to the position of each lantern. To do this, we will use, surprise, surprise, a node called copy points. The source is our create point grid, and the target is the points of the lantern. And to use the right one, we need to take the last one after the density filter. Otherwise, we will just copy points to, let's call them ghost lanterns. They are not really there anymore, but we want only to keep them that are visible. So let's take the density filter, the last one before we spawn the static mesh actors of the lantern, and put it into our target of the copy points. And now if we enable it, you will see that we have all the points here. I will make them again a bit bigger, like 0.2. I now have points around my lanterns. I think I have the feeling it's a bit too tight. So let's change the extents to maybe 150 because we want to have more flowers, and make the cell size a bit smaller. Let's do 30 by 30, 30. So it's a lot of flowers, but I mean, a single flower would look silly. And now what we do is from here, we are going to do a static mesh spawner, and we will spawn flowers. Okay, so create a static mesh spawner node, and as the mesh entries, just open up, maybe create 2 or 3, whatever you like, and let's select the poppy, and it's the S field poppy, and by selecting it, you will see that I will get immediately some nice flowers inside of my, or around my lanterns. And let's do the last one here as well. Let's take this one. And now I have flowers. Not really looking supernatural because it's a bit too geometrical, hard word. So we have to add random values, and we have 2 positions where we can start to break it up. We can, of course, as the first one, distort this grid. The grid is perfect the moment we spawn it. So maybe it's a good idea to already make this one less perfect. And to do this, we will add a point transform in between as usual. And we will put it here in the source. And we can change the offset values to move the points in different direction to maybe something like -10, -10, 10, and 10, and rotate it by 360. And maybe it's not enough. So let's do -50. Let's go a bit more crazy. And now you can already see it's less perfect. This side here is actually not looking too bad. This one here is too square because it's just one grid, and that's fine. To make it more interesting, we can also remove points. So at the moment, this grid is again looking pretty perfect like a grid. So if we take the noise, the density noise, and take a density filter in between and add it here, we will lose a few points. Maybe that's too many, so let's change it on the density filter to a smaller value. And now we will see that we have a bit more space in between. It looks more natural, and it's actually not too bad at all. There's one tiny but super important tool that I kept a secret so far. And I don't know how many people here are able or ever used Houdini, but with Houdini, you're able to inspect all the points. You see all the values and you see the amount of points. We can do it here as well. So let's select the density filter or any node, not really important, and hit A. You will see that we not only have a blue dot, we also have a yellow dot. The yellow dot means it's in the analyze mode, but the attributes here are still empty. So to change it, you select your PCG Fox demo here, and this will give you information of all the points that you have in this node. At this node here, we have an index, we have the position, we have a rotation, we have a scale, it's always the same scale, and we have a density value and a steepness value. In total, we have 69 points. So this information are all stored on the points, not on the geometry. When we go back, or when we keep it on and change the value here, you will see that the point count is changing, we're adding more points to it, and we get all the information. It's the same with the transform points. The transform points is changing the position and the rotation. So this is a super, super helpful tool once you get the hang about it and understand how it works. It's really helpful to read in the information and figure out why is my rotation not offsetting. And then you hit analyze and you see, okay, I'm not transferring my rotation at all. So use it when you need to get a bit more information about it. Let's disable it by hitting A again. So nothing is in analyze mode. And all we have to do now is we will just create another random node and another density filter and another transform points, or we just copy these 3 nodes, copy them, paste them in, and instead of going straight to the static mesh, we will just add it in between. And now we have less flowers, everything is random, and if we just, or we can even add random rotation in all the angles. Let's do something like this. And now you can see I have not really evenly distributed one. The size is all the same. That's maybe a bit boring. So let's change the scale from 0.11 to 0.8. So we have a few that are smaller and we have a few that are taller. And now we are ready to enable everything in our scene. And to do this, we can just go to the static mesh spawners, hit E, hit E. And now we have the grass, the paths, the rocks that are not intersecting. We have the flowers around the lanterns and the lanterns that are near the fox. And if I move the fox, you will see the lanterns are moving and the flowers, maybe I'm too far away, the flowers are always spawning near the lanterns. Coming back to our example with the toilet, just imagine somebody saying like, the position of the fox is not good, let's move it over here. In a normal world, you would have to place the lanterns, and if you have a foliage tool, you would go in and paint it, and paint a flower here and paint a flower there, and then something is changed, you go back to foliage, and you change it all the time. But now we have the option to do it interactively. And that's actually the most important part. There are two small tools, but I think we keep them for the last. Oh, let's do one thing. We have the gate, but I think the gate is just another static mesh. Let's do something more interesting and a bit more mind-blowing, not really, but something that enables you a lot of different workflows, is using the distance from the fox to drive the size of the flowers. So the further the flowers are away, the smaller they are. Maybe not the most logical order, but if you have the paths, for example, you would say all my trees near the paths are smaller, and the further away, the bigger they get. And to do this, we will utilize the density again. We first have to get the distance from the fox to the flowers, and then we will use these values that we just created and multiply the size of a flower with it. And to do this, again, we will grab parts from our old network. We can just get the get actor data of the fox and the distance. Let's just steal them. And as Robin said, we like stealing. Let's add it in between. So nothing changed, all good, that's perfect, because we like our position of the flowers already. We don't want to mess with them. But now we have the distance here. When you, let me just. The points are really small from the flowers, so maybe we do a transform. Bounce modify in between. Oh, wrong position, sorry. Bounce modify. And make it a bit bigger so it's easier to see. 3 by 3 by 3. Okay, so now I have my flowers and I have the gradient offset here again. So it's like the flowers here are grayish, they are black. And now what I want to do is I want to use this information that I have to change the scale. And for this, there is just the node called math. And I think, yeah, it's the same. I was just afraid that they changed it in 5.2. So if we add this one here as an input A and also as an input B, and we just connect it, you will see nothing changed because the operation is doing anything. What we want to do is we want to multiply it. And let's have a look here in our distance and go to the analytics. You will see that you have a value called scale. And we want to change the scale based on our density. So we want to multiply the scale by density. And that's actually all we have to do. So instead of adding, we will just go to multiply. And when we go to input source 1, you can hit this plus button and select scale. And in input source 2, we will just select density. So now we are scaling we're multiplying the scale by density and outputting it into nothing. So nothing is changing. So instead of Nothing. We want to save it as a new scale value. So if we add it in, you will see that we get these wonderful values. So it's actually working, but not really. Now what we have is that points that are further away are bigger, and the ones that are close are smaller. And to control those values, we can remap the density before that with a node called density remap. And if we plug this one here in between, we now have two sliders in the density remap node where we are able to change the values. And we realize that at the moment, the further away, the bigger they are. So we change it that the minimum scale of a point is not 0, it's 1. So everything that was black is now white, and now everything is changing. And now in this node, I have the option to say, I don't want to have anything, the points should never be smaller than, for example, 50%. So I can change the values here. And now it's maybe harder to see, but the points here on this side are smaller. I can enable it and disabling it. And now it's changing, and the size of the flowers are based on the position of the fox, based on the position on the lanterns. And this is actually where all the fun begins. When you now drive attributes and densities on scales and rotations based on other objects, then it's getting really complex. You can start with blueprints and have an object that is always looking in the same direction as another object. So for example, having sunflowers that are always looking in the direction of an object, and the object could be a fake sun, so the sunflowers are following the sun. Or having two characters looking at each other, and elements like this. And this is really where the power of PCG is starting, and it's getting really, really interesting and powerful. So let's enable everything back on. And now we have the scene and everything is working. And to prove to you that this one is a landscape object, I will go in the landscape mode and I will just start, oh, that's a bit too much. And I will go to the tool strength and change it to something a bit more subtle. And I will just, that's a bit too subtle. But you will now see that everything is regenerating and all the points are still in position, even though I'm changing my landscape on the fly, and everything is recalculated and it's still working. And this is the interesting part now. So now what I meant earlier is like, we created our setup, we created our rule set, and now we can start to be creative and work with it and exchange objects. And instead of lanterns, we maybe want to have trees, or instead of stones, we want to place characters. But now the rules are working. The path is always removing the objects. The flowers are always near the lanterns, and the rocks are never intersecting with the fox. And that's, I think, all that I have here for this example. I just want to quickly show you something, a little something that is not the usual PCG example. And then we can switch over to the Q&A. Because for me, as I said earlier, I'm coming from the world of Houdini. I like to do stuff with procedural objects. And PCG was fun, and I was always sitting there like, why shouldn't I just use foliage? I mean, foliage is working, and I can spawn foliage based on textures on a landscape layer and so on, but what is the really big advantage? And then I was just playing around and find a really, really simple setup, but was for me one of those, nice, now I see where we are going. So as you can see, I have like 3 statues here. I have the first one, that's the lion from Quixel. It's all from Quixel. And this one here is covered with plants. And I made this small PCG setup. And if I take it and move it over to this statue, it will take a few seconds and it will calculate it and it will place the plants on top of this object. And I can, of course, do the same here on this size. And whatever I'm doing, it's always placing my plants and covering objects. And I remember it from older animation projects where we had to cover heaps and heaps of objects with moss. and Ivy and whatever. And it was always a pain, and suddenly something moved and it's like, oh, now I have to start from scratch. And this one here is working in real time. It's just recalculating, and I can just duplicate it, and I can have another network here for this plant. And then if you realize, I don't like to have it covered in the moss, I can change the static mesh spawner and replace it with flowers, or I can even replace it with other objects or mushrooms or whatever. So it's like full control. So if I, instead of the archangel, I say this will kill my scene, I will take the lantern. It's still working. I mean, it's a bit, if we take mushrooms, it's Last of Us. So this was for me one of those examples where I suddenly understood that PCG is not just landscape tools. It's world building in general, but you can do way, way more than just having a path that is going through a tree that is removing all the objects. It's a great example, and we did it ourselves, but I just want to say to you, it's like, try to think out of the box. I think PCG is super, super powerful and is super, super fun to just play around with values and do everything. And this example here is also in your scene. So if you want to grab it, it is in the result PCG, and it's called PCG_cover. It's really simple. It's just taking a box, projecting points from top to bottom, and wherever the ray is hitting, it will create a point. And on this position of the point, we are spawning objects. That's it. Super simple, super powerful, and a lot of fun. And I'm really, really happy that we have tools like this now inside of Unreal. And with that, I think we're done with all the elements. Like I said, the PCG fog setup is in the project folder as well, so you can have a look. It's all there. And if you have questions, of course, feel free to just ask on the Discord server. There's no PCG's channel yet. Maybe we have to create one, or have world building, or just ping me in the general chat and we will find a way to get it done. And disclaimer again, everything is new, everything is changing all the time, and it's not well documented.
All right, thanks a lot.